All right, so let's start these notes. We need to talk about naming polynomials. So let's talk about um, this word polynomial. Um, what does the prefix poly mean? Does anyone know? Many, yeah. So this right here, poly means many. And then nomial is kind of like, what's nomial mean? So this is like, um, it can mean like terms. Oop, we'll talk about that in a second, what that means. Okay, so polynomial means many. We're going to be naming these two different ways. We're going to be naming them based on their terms. So we want to circle that word and the degrees. Okay. So we're going to want to make sure that we kind of distinguish between the two. Sometimes people get confused on which one's which. So terms. So a term is like, it almost makes more sense for me to show you what a fourth term is, or so it means like how many different parts there are. So if I said like 5x to the third plus 2xy plus 7z plus 9. Can you explain to me why I would tell you that has four terms? Why do you think that has four terms? Yeah. Okay. Kind of four variables, kind of. Sure. Sure. By the addition, there are four parts broken up by addition. 1, 2, 3, 4. So a term is like each of those addition blocks. Okay. Can we close Chromebooks, please? So I'm not going to tell you the name of that one just yet, but do you think you can give me a 3-term polynomial? Yeah.
2x
Uh-huh.
plus 5y
Uh-huh.
plus 2y.
Now here's the catch. If he says 2y, I'm forced to take the 2y and the 5y and put them together. 2xy. Okay. He wanted to say 2y originally, but I would have to put those together. These three things cannot be put together, so there's 3 terms. Okay. What happens when you forget your lunch money? Oh, you do go into that, right? They actually let you have lunch. What if you forget your lunch money when you go to Subway? You don't get your lunch, right? You try no meal. If you forget your money, try no meal. So, try no meal, yeah. Where does the try come from? Right. So really, this is saying like 3 terms or 3 things. Does that make sense? So the prefix try is like trinomial. Okay. Someone give me a 2-term polynomial. Jasper, sure. Were you raising your hand? Oh, yeah.
2x plus 6y.
Perfect. Okay. Oh, I think I messed up my joke.
Why?
Because this one was supposed to be what do you do if you don't have any money? This one was supposed to be trinomial. If you don't like what's for dinner, trinomial. What would this one be? Binomial. Did someone say that? Did I hear that? Where does the prefix bi? What does the prefix bi make you think of? 2, right? Like bicycle, Bilingual. What does it mean to be bilingual?
Speak many languages.
You can speak. Technically, bilingual would mean 2 languages, right?
Are we gonna need to know these names?
Yes. And then we have what would a one-term polynomial look like? Yeah. 3x, love it. Okay. This one is what is it when you eat by yourself? Anyone know what the prefix for 1 is?
Singular.
Okay, uno, no, mono. Monomeal. If you eat lunch by yourself, that's called a monomeal. Just kidding, not really called that. But anyone want to guess what the 4th one is? And you'll probably get it wrong.
Quadrillion.
Okay, I like that guess. Here's the deal. In this class, we only have to know the first 3 terms. What do you think the generic term is for higher than 3? It's polynomial.
Oh yeah, I got it right.
If we have more than 3, we're just going to call him polynomial. Okay? And really, no one's going to ever ask you more than that. I have a degree in mathematics. I don't know what. Yeah.
Really?
He's a math teacher.
Get them, guys. Get them. It's true. You could get a math education degree. I have a degree in mathematics and a master's in education.
Why are you teaching 8th, 9th grade math?
I don't know. I've made a lot of mistakes in my life. I'm just kidding.
Like a college professor.
I have taught it. I've taught at Columbus State. Okay. All right. So now we need to talk about degree. So these are terms. And remember, terms are separated by addition. Degrees. Degree is just a fancy way of saying what is its power. Okay. Degrees is a fancy way of saying what is its power. And you always look at the largest power wins. So for example, if I went down here and I said 3x plus 5x squared. Is that someone trying to leave or come? Someone put that in? Yeah. Okay. I don't think it's a good time to go, but if you want to go, you can go.
Yeah, it's a bad time to go.
But you can if you want. All right. So even though the 3x came first, we look at the highest power. The highest power here is 2, or we would say the highest degree is 2. So the degree of this thing is 2. Okay? Anybody know? These ones are not as cleverly named. Yeah.
Oh, I was gonna say the name. I was gonna say one of the others. I don't know the name.
Okay. You want to give me another one?
Yeah.
Okay. So give me, sure, the third one.
Oh, like I could just use 3x plus 5x to the power of 3.
Yes. So what could happen though is it really, yeah, it's the highest power. So we could have 3x, we could have a 5x squared, and then like a 1 or 1x to the third. I don't really need that 1 there. Sometimes people want to make x squared the highest power because of the 5, but that has nothing to do with it. It's just what is the highest power out of all of them. Okay. Anyone want to guess what this is called? So we're not going to call them nomials anymore.
What?
These over here, the other ones are all based on terms of the nomials.
Third degree.
Third degree. What's a thing that means the third power?
Degree.
Right? What is it? Does anyone know if I raise it to the third power, what we call that? Cubed. Cubed it. So this is called cubic.
You're not ready till the last.
Second power is really, really weird to me. It's called a quadratic. In terms of what makes sense, I hate the term quadratic because quad makes me think of 4, but it's that's what we call a second power. We should know. So let's I'll give you a 2 like this. So if I say 5x plus 2, we actually know what this is called. We just never talked about it in this terms. Anyone want to guess what it's called? Yeah. Okay. I mean, what's the name of it? So function, equation, yeah, we're hitting there. Anyone? Yeah.
Wait, actually, no, that was stupid.
Linear.
Linear.
I know all these words.
Yeah, we know linear, right? We've studied linear a bunch.
Oh, I get it.
Now, when we say the highest power, we're talking about the highest power on what? I'm going to call that a point. Okay. Say again. On what though? It's the exponent on to the variable, right? It's not about the number, it's about the variable. What if we have an exponent of 0 on the variable? What does that mean it actually is? It's 1. So what would be a 0 degree? Give me an example.
It means like you're.
So if
You have 0 degrees.
so, yeah. So can someone tell me what this? Give me an example of a polynomial with 0 degrees. Yeah. I like 5x to the 0, but we would not write it that way.
Just 5x, right?
No, just 5, right? We would write it as really just 5. It's really just a number, right? Because in theory, we can say that there's an x to the 0 next to it. It is kind of weird. Anyone know what this is called? Okay. What's it called when you don't have a variable?
Oh, it's constant.
It's constant.
Maya, I was thinking. I'm really trying.
It's good.
Then you say constant.
I did.
Here's where we have to be careful, and I made myself a little note to not forget this. So, 5x, y, z. What degree do you think that is so far?
0. 1.
It's not 1.
3.
It's 3. Why would that be a degree of 3? Yeah.
Oh, 3 variables.
Because the variables all have a 1, and in that term, we need to add the variables together. So this right here is actually a degree of 3. It's not an example of a degree of 4, but I want you to know that that is a degree of 3. So plus 2xy to the third. What is that thing's degree?
6.
Oh, I got a question.
Yeah.
So can we have? Can there be an exponent above, like if the x, y, z are it's all together? Can you have an exponent above each one? And
Yes,
if you add them up, that you have to add them up.
you do.
Okay.
Yes. So this one here, what is its degree of just that term?
4.
4. So what's the degree of the whole thing? 4.
9.
It's actually 4. Each term is its own thing. So in a sense, this right here is a third degree. Just this one term. And this is a fourth degree.
But it's 4 because it's the highest.
And then we call the whole thing based on the highest, so that is a fourth degree.
Like, can you repeat that one more time?
Sure. So whichever is the highest is the one that's going to win for the whole thing. So we're saying this whole thing is a fourth degree. This is a 1, 1, 1. So you add in just that term, those degrees, or those powers, and we say that that one part is a third degree.
Oh, Oh, so you don't add all the ones together.
Yeah, so just in those terms. And then in this term, there's 4. So we say overall this thing has 4.
Oh, okay.
Okay.
Yeah.
When we have higher than 3 degrees, we don't name them in this class. We just call them.
I was just confused. Wait, there's technically a 1 above the S, right?
Technically, there is a 1 right here, yes.
Is that what makes it the 4th degree?
Yeah.
That's where I was confused. I literally just called the 4th degree.
Anything higher than 3, you don't have to name, you just call it the 4th degree.
Or you call it the 5th degree.
So really, there are names for these things, but in this class, you just have to know 1 through 3 on terms and 0 through 3 on in terms of degrees. Okay. Just for funsies, 7x squared y to the 7th plus 2x 3y to the 10th z plus 6x 7y z to the what do I want to do? The 3, 6, 8. What degree would this thing be? It's much higher than 4.
Well, yeah.
So you have to add them all.
It's more than 10.
20.
It'd be 16. 16.
No, wait. Oh, there's a 1 above the Y. So it's 8 plus 7 plus 1, which is 16. It's 16. 39.
Okay.
16.
It's either 16 or.
I hear 39, here 16. Who's in the
No,
16 camp?
I think it's 16.
Who's in the 39 camp? Who's not camping at all?
Yeah, 36, 37.
Oh, 37?
Yes, you do.
You just go to
Mic drop.
you go to
Yeah.
plus the road. 16. Yeah.
Oops. Oops, my bad.
Remember, each term is its own thing, right? So this right here is 9. Is that the highest? No. This one here is 14, and this one is 16. We only name it based on its highest term degree. So that would be called 16. Why don't you high five them back on the midterm?
Hey, that's funny.
Do you need some aloe?
What?
You need some aloe?
No, I'm good.
Your burn's okay? Okay. Sorry. All right, so name each polynomial based on its degree and term. So that means each one of these is going to have how many names? 2. Anyone want to tell me? We always start, for some reason, but I would not mark it wrong, but we always start with the term. So we always say the term first. If you said it backwards, I would not mark it wrong. Can somebody tell me what this thing is called? Yeah. I said that backwards. We start with the degree. I said that wrong. But go ahead. What is its degree? 3. So we'd say it's a cubic. And then based on its terms. Yes, I think I heard it. Monomial. Yeah. So naming it based on its degree and its terms.
Wait, how is it mono?
How many terms are here? How many things are separated by addition? There's only one thing. Okay. So we could do this to help us out. We got terms. And then what's our highest degree?
Wait, this subtraction work. Oh, yeah. The next 3 terms.
What's our highest degree? And then our degree, this is a 2, right? So what do we call a 2 degree 3 term? It is a quadratic trinomial.
The degree always has to go first, right? Or does it matter? I'm just wondering.
The degree, yes. We usually say the degree first. If you said it backwards, I would not mark it wrong.
Okay.
What in high school, like, teachers?
They wouldn't mark it wrong, but it would just you would just be saying, yeah.
They wouldn't mark it wrong.
I don't think so.
If so, you'll come talk to them.
I'll get them. I'll say, you know who I am. Okay. Write the polynomial in standard form. Anyone want to guess what it means, standard form? Yeah.
Why?
Like on the graph?
We're not graphing, no. I'm going to write it in standard form, and you tell me why you think this means standard form.
You put it in order.
Put it in order of what?
From least to greatest.
Of.
From the grade.
Hold on.
Let's use our new fancy
Of
word.
the highest
Degree.
Degree. Highest degree to lowest degree.
Oh, you also put it from lowest term.
That the term means nothing.
Okay.
It's the power. It's all about the degrees or the power. So what's the next one?
8, -8y.
Negative 8y squared
And then 2y.
plus 2y
-3.
minus 3. So again, highest power down to the lowest power.
Wait, what would you call it if it? Never mind.
So this is kind of important, the standard form, because it makes it, honestly, it just makes it easier to work with. It makes it easier for me to grade. So I want to point out on here that this says simplify, and then I want you to write it in standard form. Okay? If you don't write it in standard form, then it's easier to mix up what's going on. If you have ties, if you have x to the third and y to the third, that order won't matter. Okay? What we're doing here is we are adding common or like terms. Okay, so let's write that down here. I'm going to write down here real big. And we've done this a bunch in our classes before this class. I like to go, and I'm going to go through, and I don't know when you learn how to combine like terms, but I like to put symbols next to like terms. We're going to go to the highest degree. So what I'm saying here, what is our highest degree out of all of these? Okay, so I'm going to circle it. Are there any other 3x or any other x squareds?
Yeah, the 2x, right?
Nope.
Aren't they all to the second? Or all to the first?
Well, these two are. So there are no other x squareds. So that has nothing. There are no other like terms. So that means we get 3x squared. Okay. Now I'm going to underline all of the next powers. 2x and negative x equals just x. So I'm going to write plus x. And then finally, I'm going to combine the constant term. There's only the 9. I don't know. I'm going to put dashes underneath it.
Did you already put it in standard form?
It is in standard form if I do it this way. That is correct. So then plus 9. Because I always like to go find the highest power, find all those. Find the next highest power, combine all those.
I'm confused why you put parentheses around everything.
Because they're saying that this is a thing and this is a thing. So what they're saying is I'm adding this binomial with this binomial. What do the parentheses do? Nothing. They do nothing. They're just saying I'm adding this thing with this thing. Okay. So in the next problem, and it doesn't matter how you use symbols. I just want to use the same symbols for each of them. So I might say, okay, here's my x squared. So I'm going to underline all my x squareds. Do I have any others? No. So I go negative 2x squared. And then I'm going to I'm going to do squiggly line under all of my just x's. So that's plus 8x. And he says we're done because these two equal 0. So yes. on these two problems, you probably could have gotten away without writing the symbols. You could just like kind of look at it and figure it out. But as these get more tricky, the symbols kind of help. Okay, especially when we get to this one. But we're not there yet. Okay. Here, what are these, how are these different than the ones we just did?
Oh, it's a minus.
It's a minus. We do not like minuses. So what I'm going to do is I'm going to make it a plus, and I'm going to change that. You can, but I highly recommend not doing it. Get rid of the minus because there's going to be so many steps it's easy to get lost. I'm going to distribute in the minus. What happens when you multiply everything by a minus? Switches the sign. So this really becomes a positive x minus 4.
Why are you not doing to the stuff to the left of the minus on the other side?
Because there's nothing to distribute in there. I'm just getting rid of the minus, and then I'm going to bring this down. And then now I have it as a plus. I just put this plus. I don't like that plus right there. It bothers me a little bit, but I only put it there to show that it switched signs. So now I'm ready to do like the other side. Okay. So I go 3x squareds. Any other x squareds? No. So I write 3x squareds. Then my x's. How many x's do I have? 5. And then finally,
I like doing standard form better than the other ones. The other one I have to like memorize the rules.
yeah. And then finally, what's my last term?
Minus.
-2.
Can we try and do the other one ourselves?
Sure, you want to do B? Let's race on B. On your mark, get set. I'm going to drink some coffee. Oops. Excuse me, sorry. Okay. Some of you might be tempted, and it's not wrong, but some of you, and really, we haven't gotten to the part yet where these are terrible. But when they get terrible, some of you might get tempted to go, I dealt with that, and then I dealt with that, and cross them out. Why do you think I don't like teaching that we should cross them out?
Because then you forget about them.
You might forget, but if you make a mistake,
You get that right.
it's hard to see, right? Especially if you start crossing out the original problem. Okay. Did I get it right?
Yeah.
Okay, cool. All right, so this is the extreme of what we've been talking about. We should race?
No, there's no. Yeah, we can raise. Wait, Bob, just one question before. You don't have to, well, the only thing you have to, for the minus at the very end, when you're minus those last two, you just have to do is that last.
Yes, we're going to distribute in that negative at the end.
Is that what you want to do first for all these?
I would always get rid of the minus first. Let's do it. On mark, set, go. I'll give you a head start. I'll take a drink.
Okay.
It's president. Mr. McConnell. Hey. Sure. Yep. Bye. Oh, I missed one.
Yeah, please.
Stop going fast.
Yeah.
Okay, yeah, we don't need to race on this one.
Yeah,
How?
I finished.
I'm not done yet.
Yeah, I finished. I'll go back.
I always like to put symbols so I know what's going with what. And then I look at it and I realize I've marked everything to make sure I didn't miss anything.
Okay, yeah.
Did it?
Yeah, I not get that.
Anyone get this?
I haven't even gotten to that point yet.
Exactly.
Gave up.
I'm
Wait.
When you guys did like terms, did you get taught to like circle some, put boxes around some, triangles around some?
Trying to do.
Okay. Yeah, that's another method. Is sometimes people will go, circle the common terms. This guy didn't have a partner.
The only one that has a line under it is the highest degree, right?
You want to go to you want to find the highest degree first, and then find any matches.
Okay.
Then the second highest. So I did this one first. Then I did this one, and it had no matches.
Oh, then you have to, and then every. Wait. How do you get the?
So the Y is connected to it.
The Y is connected to that.
So to find a match, you'd have to have
And X to the fourth Y.
an X
Has to be exactly the same.
Wait. 6x to the fourth y.
Only
You
thing
don't
that could be
put that.
different. The only thing that could be different when you combine them is the degree.
Is the coefficient, yep. And then I combined my x squared y's. I had an x squared y here. I guess different colors would be kind of nice. An x squared y here, x squared y here.
Wait, I'm confused. Why do you?
And what did that equal? A 2 plus 3 minus 5. It's just gone. And then I had my xy's. I had this one, and this one. And then finally, just my numbers, which was this one, and this one, and this one. Yeah. Say again. Which color? Green. So my green ones were 1, 2, 3, right? A 2 plus a 3 minus 5 is 0. It's just gone. You're welcome. Don't worry about naming this. It doesn't actually make sense to name it. Right over there, bud. Just bring it back at the end of the day, okay? Thank you.
Why do you circle the 6x to the fourth y in red? Shouldn't it be?
And I didn't circle anything else because there's no other x to the fourth y's.
So what do you do?
So it just came down
Oh,
here.
you just keep that by yourself.
Yeah. Same with this first one. We good?
Yeah.
All right. Can I move on?
Wait, I have a question.
Yeah.
So you're not writing down like more combining all of them. You're just writing down which one's like the highest.
We are combining all of them. I cannot add these two things together because they have different terms.
Okay.
They have to be exactly the same to combine them.
All of the pink like circles are all combined.
Yeah, the pinks got added, the greens got added, the square got added, but there was no other. There was a red, and then the yellows got added. All the like terms. Okay. So here's another one that's kind of like that. What does it mean to find the perimeter of something? It means to add up the outside of it. I'm adding up all of these. Okay? So what I want to do, and I'll go ahead and use my colored method. And if you don't have colors, you can just circle some under. I like to underline and do squigglies because even over here, my plus, like, is that a negative or not? Kind of gets lost. But if you like, whatever method works for you. So I'm going to start with my x squared. I've got a 4x squared, a 6x squared, a 5x squared, a negative 4x squared, a negative 2x squared.
You actually have to do like geometry. You actually have to do
Yeah, we just add up all the sides. What is 4 plus 6 plus 5 minus 4 minus 2?
So 10, 15 plus negative 6 is 4. Sorry, no, yeah. It's not. I meant it's 14 plus. It's negative.
nine.
Sorry, it's 8. It's 8.
9.
Wait.
I think it's 9. So it's 9x squared. 4 plus 6, 10 plus 5, 15 minus 4 is 11 minus 2 is 9. Next, I want to do just the x's. So I got a minus 5x, a 3x, a 25x, and a 15x. So negative 2,
48.
23, 38.
Oh, I got 48. What?
How'd you get 30?
I got 48. I don't even know you.
Yeah, I think it.
There's 15 plus 5 is 20 plus 3.
There's a negative. What's the negative?
Oh, I
see
didn't look
negative
at the
5.
negative.
I didn't see the negative 5.
Yeah, me neither.
So 38. So plus 38x. And then finally, the last thing, I guess I'll underline in blue. We got a negative 8, a negative 2, a positive 400, positive 16, and a negative 9.
It's 300. You mean 96? 300.
It's 498.
What? It's 398. It's
Oh, the 6.
394.
My bad. The 6 is positive. That's 394.
It's 394. 387. 3 what?
Look, the negative 8 plus negative.
Wait, it's 400 minus 10 and then
So let me do it again. So I got negative 8.
Negative 9. I've not seen the negative 9.
neither did I.
Now, this is why I like to mark all of them. Would you agree that I've dealt with every single part of this? Because I have a little underline. So that kind of helps me to make sure I didn't miss anything. That's probably the hardest thing, is to not miss something. Okay. Now let's do this last problem. This one is a little bit trickier. Find the surface area. So we want to find the area of the surfaces.
15x.
Close.
Wait, so
This front one here is 15x squared because it's length times width.
and then the other, and then the one on the other side is 15.
There's one on the other side. So I'm going to go ahead and write that out here.
30x to the 4.
So here's a huge thing we got to know. So I'm going to write this side note up here. 3x times 5x equals what? 15x squared. 3x plus 5x equals 8x.
What if it's like?
Hold on 1 second. I want everybody to write that down. That is the biggest mistake. That's a big sad face. I know math teachers who, when they see something wrong, this is one of those things where if you do it wrong, they're going to put a big sad face. They're going to give me a call. I'm going to be like, I don't even know that kid. Okay, I think Miss Walters had that kid. Okay, because I would have taught them better, huh?
So if it's what if it's 2x times 3x times 5x would it be the third?
It is.
Okay.
Okay. All right. So we got the front and the back. What is this top?
20x to 20x squared.
20xy. Oh, I lost my 20. That means that there's a 20xy on the bottom. I'm going to write it here. Say again? You could. And then this last side here, what is this? 12xy, which means there's a 12xy on the other side. Some of you are making me incredibly nervous because you're not writing stuff down anymore, and this is where it gets tricky. Okay? So now I've written down all of the areas. To find the total surface area, I need to do what? Add them. What is our highest power? This one and this one. Which one is a higher degree? They're the same. So it doesn't matter the order. So I'm going to do, just for whatever reason, I'm going to add my x squareds. What do I get? I get 30x squared. Then I'm going to add my xy's. Yep. When I add those up, I get 40, 50, 64. Is that what you said?
Yep.
64xy. That is the surface area of that shape.
I like surface area, but I don't like perimeter.
Questions like that.
A lot of people can't hate surface area and can't do it. I think it's easy.
When you understand it, it's not bad, but if you can't see the back and the front and get lost, it's confusing.
I just always multiply them by 2.
Group quiz. I want to point out that there's no geometry questions on the group quiz because those questions are online. Okay. Other thing I want to tell you, 3, 2, 1, is this one. I'd be okay if you didn't mark these things up, right? But when you get to this question, I think you need to mark like I dealt with that, because that's the easiest mistake is to think, oh, I already did that, and to leave a part out. Okay. Also, make sure that you write them in standard form. I'm going to just kind of tell you that I want it in standard form. Okay. If they tie, it doesn't matter. If it's x, y, and x squared, those orders don't matter. But if they're a higher degree, you need to make sure you put it in that order.
So terms separated by addition, also be separated by subtraction. 5p squared and 92.
Yeah, can it get something like subtraction?
Say again.
Can you separate terms by subtraction?
Yes. I would call this would be called 4 terms. Is that what you're asking? Yes. But you need to combine them first before you call name. But we're not naming on here except these last ones. But yeah.